Z drives were intended to be accessible all across campus.
Yeah.
So I haven't posted grades for assignment 1 yet. I haven't even graded assignment 1 yet. And the reasoning for that is I use a script to collect all your assignments and build them and then spit out some output so that I can go through them and read them and check things off and figure out what your grade's going to be. I recently moved from my place of work from the lab 2 doors down to my office down the road, which meant I had to give up some machines, and one of the machines was the one that was running this script. So I didn't lose anything, it's just not set up on any other machine. So I'm in the process of doing that. Grades will definitely be up by the time the next homework assignment is due. Hopefully by Saturday, if not on Saturday. That said, any questions on Chapter 3? Anything that looks like a typo in Chapter 3? Or will we discover some of them today when we're going through it?
They mentioned the front cover again.
They mentioned the front cover again. Awesome. Okay, so what does it say is on the front cover?
Just the same thing it did previously.
Oh, the list of Java keywords?
Yes.
Okay, there is a Wikipedia article that is named something like List of Java Keywords. It's exhaustive, describes everything about the keyword you could possibly want to know, and then some probably. So if you need a list of Java keywords, check out the Wikipedia page, since apparently they changed the cover without telling the author. Any other questions on Chapter 3 before we dive in? Yes?
When you're doing your else if statements, and before it gets into just compounding them, or before it gets into doing else if, it just does if else, and it talks about if you want to do a compound statement, you include it in brackets. Now, when it goes into doing else ifs, can we do that whole thing in brackets and do compound statements for each else if?
Yes. Yes. So the there's actually a grammar that describes how Java, the language, is constructed. And the way the if-else statement is constructed in that grammar basically says you need an if, and then you need some statement, and then an optional else, and if you have that else, you need some statement, where some statement can be a single expression followed by a semicolon, or it can be a block, which is a collection of statements surrounded by curly braces. So anywhere you can put a statement, you can also put a block.
Yeah.
I think that's pretty much
Because that's what they have. They got the Boolean expression and then the statement that comes after that. And then you can also write conditional statements.
Right. But if you want them to all be under the umbrella of that condition, you need to put curly braces around them to make them a single block. Technically called a block statement, but that just makes things confusing. And there's a really good illustration that I saw in, let's see, I think it was C++ The Complete Reference, written by a guy, I believe his name is Herbert Schilt. He also wrote Java The Complete Reference. I think there's C The Complete Reference. But in this particular volume, it's massive. He kind of shows the origins of the if, else thing. And basically says that the construction of the if-else statement is if statement, optional else, followed by a statement. However, the if-else structure itself is itself a statement. So instead of having if statement, else, single statement, you can say if statement, else, entire new if-else statement. And if you rearrange things, Java doesn't really care about white space. You can make it look pretty, and that's how you end up with if condition statement, else if condition statement, else if condition statement, else statement. And if you think about it that way, I think if-else statements become a lot simpler to understand, because you can get some pretty complicated if-else, else if structures. They're big and massive and ugly. But if you think of it as a single, I'm testing a condition. If it's not that condition, let me check some other conditions. And you get this, he calls it a ladder, because if you keep indenting, you end up with this kind of staircase sort of look. Kind of cool aside about if-else statements. Other questions about Chapter 3? Alright, so Chapter 3 represents, I mentioned there are 3 things that make a programming language / computer able to solve all problems that can be solved by computer. Sequence, selection, and iteration. We've talked about sequence. There's only so much you can beat a dead horse as far as selection is concerned. That basically amounts to variables, expressions, statements, pretty straightforward stuff. Start at the top and keep executing until you hit the bottom of the program. That's good for starting out, but it doesn't make for very exciting programs. The program will do one thing all the time, every time, and that's the only thing it can ever do. Certainly we can't write Windows with just sequence, rather. We need some way of choosing to execute a certain piece of code or a different piece of code based on some condition. And that's what selection is. And Java provides 2 ways for us to do that. Java provides the if-else statement. Usually I refer to it as the if statement. The else is kind of just follows. It's optional. You don't have to have an else. And there's this switch statement. I always have to think about that one because other programming languages call it select. Java calls it switch. Right. If-else statement. The basic structure of an if-else statement is, like I've already said, if condition statement, else statement. Yes. So, let's see. I mentioned this grammar thing, and let me turn off some of the lights. So in this grammar, it looks something like if condition.
Why do you need the 2?
So this is not actual source code. In this particular way of describing how things work, something surrounded by angle brackets means that you have to put something here. You have to replace this with something.
Oh, that's
and then
the variable.
Well, I'll get to exactly what it is in a minute. But I'm not actually writing an if statement. I'm writing the description of what an if statement is. Statement. Yeah, I can spell. Statement. And then something in square brackets means it's optional. So, in order to write an if statement, we have to have the keyword if. We have to have an open parenthesis. We have to have something called a condition followed by a closing parenthesis. We have to have a statement following that. That's the simplest possible if statement we can have. Which, let's, public class fun with ifs. Public static void and So let's do something very simple here. Let's make that just print. We might want a... I'll get to that in a minute. And if I forget, Java will yell at me. So I will remember one way or the other. Int val equals keyboard dot next int So now let's say this. Let's make this a very simple guessing game. You get one chance to guess the number, and the number will always be 5. So if val equals 5,
Does the statement have to be on the same line as
no.
if the number? So we're fine.
So right. Let me finish typing and I'll expand on that. Okay, so in Java, white space is white space is white space. A line break is the same as a space, is the same as a tab. Indentation doesn't make any bit of difference. Line breaks in your source code don't make any bit of difference. You can pretend that when the Java compiler goes through your program, it takes out every piece of white space you've put in there and inserts a space, for instance. So your entire program ends up on a single line. It doesn't matter. You could write your program, your entire program, on a single line. It wouldn't be very readable. I wouldn't be able to understand it. You probably wouldn't be able to understand it either. But it would be a perfectly valid Java program. We use different types of white space to make things a little more readable. So, and it really comes down to convention and more so than that, personal preference. When I'm writing code and I have an if statement that has a single statement after it, and that statement is short, kind of defined arbitrarily. Apparently this is a short statement. I'll put it on the same line as the if, just because it takes up fewer lines of code. I can more easily delineate that statement from other statements in the file by a couple line breaks on either side. Longer statements, I'll put it on the next line. If it's a compound statement, a block, something that where I want to do multiple statements, if this if condition is true, then I always put those statements on the next line, and obviously surrounded by curly braces. So now we consider that a long statement. So let's
Consider that a what statement?
a long statement. An arbitrary name I've given to it. I'm still stuck in the 80s when people had 80-character terminals. So if my entire statement goes beyond 80 characters, I put a line break in there somewhere so that it doesn't go beyond 80 characters. So compile that, run it, enter an integer. Let's pretend that I don't know that the right answer is 5 and just put a guess in there. Doesn't do anything because this if condition is not met. If I run it again and I type 5, that if condition is met and it prints out, you guessed correctly. So now let's talk about this condition thing. The condition that goes inside the parentheses of an if statement must be something that ends up evaluating to a yes or no value. In reality, as the next section of this chapter talks about, it's a true or false value, a Boolean value. But when we're talking about ifs, we can talk about it in terms of the yes or no question. Basically, is val equal to 5? If so, we do the if part. We can also combine expressions like this with what are called logical operators. We have and, or, and not. And is simply, is the thing on the left-hand side true or yes? Is the thing on the right-hand side true or yes? If both of them are yes, then the entire thing is a yes. Or is kind of the opposite of that. If one or the other is true, the entire thing is true. The or statement is 2 pipe characters. That's the shift and the backslash key. If I pull up a show keyboard viewer.
So, any value in your statement is false, does that make the whole statement right?
If any value in your whole statement is false and everything is grouped together by ands, then it makes the entire thing false. In fact, logical operators in Java are short-circuiting. So it basically follows kind of shortcuts. If you have a bunch of things that are anded together and it hits one of those things that's false, it knows at that point that the entire statement is going to be false. It can't possibly be true. So it just says, this is false, I'm not going to execute anything else. Likewise with ors, if as soon as it hits something that is true, the whole thing is going to be true, so it doesn't bother looking at anything else.
Even if there's something false within the or statement, it doesn't necessarily make the whole statement false, is what you're saying?
If correct, yes. More complicated statements that are a series of things that are ORed combined together using ands, and things that are ands combined together using things that are ORs get kind of confusing, and it still uses short-circuiting, but it evaluates the statement in a kind of a top-down strategy. There are specific operator precedence rules, order of operations, and I always forget what happens first. I think and happens first, and or happens second. I always don't trust myself, don't trust my memory with that, and put parentheses around things to make sure that what I want to happen is actually what happens.
I mean, what you're not
Where is that?
Figure 3-6 Java local operator because logical and logical or logical not. It's in sequence.
Yes. Okay, so those are the 3 operators. Doesn't look like they mention the order that they go in, though.
On page 169, there's a complete order.
Ah. That's useful. Ah, yes. Okay. I think that 7th line, where it says 7th, the Boolean operator. No, that's supposed to be a single pipe. Ah, right. Okay, so Boolean not happens first. In terms of logical expressions, that's the first thing that happens. Then, after several other potential operations, the logical operator and the logical operator, and then followed by the logical operator or. If in doubt, put parentheses around the things you want to happen first, and it'll evaluate those things from closest, most inner parentheses first, and then work its way outward to the entire statement. So that pipe character, like I said, shift backslash. So there's my backslash key. It might be in a slightly different place on your keyboards because this keyboard viewer looks identical to the keyboard that I have on my computer. And the pipe character is, if I hold down shift, that's the pipe character is there. The ampersand character is what, 6? No, 7. Shift and 7. And then the exclamation point is shift and 1. So let's make this a really wonky game. Guessing game. That's not going to work. Where I get it right if I guess 5 or 7. Is this a contrived example? Maybe. So if I enter 4, nope. If I enter 5, yes. If I enter 7, yes. Question so far?
You couldn't just put 5 or 7, you have to add the...
Correct. Or the AND operator and the OR operator expect something Boolean on both sides. So I can't say, though there are languages that allow you to do that, Java's not one of them. You can't say 5 or 7 because Java would say 5 or 7. 5 is not a Boolean value, but it evaluates to true. That's assuming it doesn't give a compiler error. That whole statement is true. Val is equal to true. Wait a minute. Val is not a Boolean variable, which we'll get to in the next section. So it will probably not compile. It'll say this doesn't work. You probably didn't intend to do this quite this way. So let's add the optional else. And we'll print the obvious message. And it tells me I guessed incorrectly when I typed in 4. That's pretty much the full extent of the if statement. A special note about these particular statement things in lines 2 and 3, they can be a single statement, like we have here: system.out.println some message ended by a semicolon. They can also be something called a block, technically called a block statement, but which is how it fits into statement. A block is a open curly brace, some number of statements, and then a closed curly brace, which is most often how you see if statements, because it's very rare that you're only doing one thing inside an if condition. So, yes, Jill.
What's a static error?
Oh, so you hit up and then 6 and then
Wow.
So it said I can't find it. I don't know why they call it a static error. That terminology doesn't really make sense to me. So now we have a block for this if statement that only contains one statement. Let's add something to it so it's more meaningful. Notice that I have a block for the statement for the if part, but not for the else. That's perfectly valid. Each statement instance is its own statement instance. So even if you have a block statement for one of them, you can have a simple single statement for the other one. But if I want to, I can also do the same thing for the else.
You say that you can have a single statement. Please tell me how about that.
Yes. It's not bad to always put a block there, even if it only has a single statement. In fact, when I'm writing code and I'm not entirely sure what every statement is going to look like, I often put the curly braces there just so that if I have to go back and add extra statements under the if condition or in the else condition, I don't have to worry about the braces. I don't have to worry about forgetting about the braces and having those extra statements always get executed. That's always a pain. Those are really difficult to debug, especially in a language like Java that doesn't enforce indentation. One of the big pitfalls is doing something like this. Val, let's say, greater than 4. Well, Dr. Java tries to help me out, but I will refuse its help. Lines 24 through 26 will always set val to 2. Don't get fooled by the indentation. No matter what the value of val is, val will always get set to 2, because the way Java parses this is actually like that. So if val is greater than 4, val will get set to 3, and then regardless of what it is, it'll get set to 2. Well, it's not very meaningful. What I actually should have done is that. Now val will get set to 2 only if val starts out being greater than 4. Does that make sense?
Basically, the value is 3 better.
Yeah. I just put that there so that I had another statement. I probably could have put a system.out.println and made it a little less contrived. Right, so let's compile this and run it. Right. So now, let's say 5 and 7 are correct, and 6 is It's not incorrect, it's close. I don't know. We'll say it's close. So we'll start out by doing something like this. If val is equal to 6,
So that when it gets down to 6, on the left side, else is in the bracket and indented.
right.
And the statement.
What's going on? I strongly recommend.
But you need what?
I'm sorry?
Or you need another if on that last else to keep going.
Hang on. I'll get to that in a minute. I recommend always maintaining your proper indentation. I have seen code written by people who have been writing code for far too long for this to be an issue. I have seen code that has lines indented all over the place, sometimes within the same block. Don't do that. It makes it really difficult to read, especially when you're trying to figure out what you're doing to begin with. If you change the block that a particular statement is a part of, make sure you update the indentation so that it reads well. Then you're less likely to fall into the trap of having things that are outside of the if statement when you intend them to be inside the if statement and other things like that. So now to answer your question, take a look at what I'm doing here. I have an if statement that has if, a condition, and then a statement, and then else, and then a block as the statement. Within that block, I have another if statement. So we're going eventually toward what you were talking about, but we're not quite there yet. Yes.
Did you say that you should do the else if on separate lines?
So this is kind of, right now we have a piece of code that you would never actually see in practice. But this is a first step. So the if-else statement is if statement, else statement. But we can combine them so that we have if statement, else, and then within that else we can put another if statement. So a lot of times when you would see something like this is if, regardless of what condition happens here, whether val is equal to 6 or otherwise, for instance, this line would be outside here. That's a case where you would use something like this, where you would actually nest if statements. But for now, the only thing inside this else is another if statement. And if we execute that, there's 5, there's 6, and there's 4.
So you don't need that last little one because it's the final condition statement of the source code.
Run that by me again?
You don't need the extra if on the last else because it's not having another else after that. It's the final else.
Right, it's basically a catch-all. And no one yelled at me. My indentation is wonky. There we go. That's better. Yes.
Can you combine the second else with the else if and just do it all on one line instead of doing else and then if?
Yes. So that's the quote-unquote right way to do it. It's a lot easier to read, and the reasoning is that an if-else structure is itself a statement. So it can be the statement for either the if part or the else part. It usually doesn't make sense. Excuse me. Usually doesn't make sense to have it be the if part because it looks kind of confusing and messy. And if you're doing that, you might as well test for one condition that you know to look for, and then handle every other condition in the else. So instead of having a block and then an if statement inside this block, we can just have the if statement directly, doing away with these curly braces. And at this point, it's perfectly valid. It explains exactly what it does, but it's kind of difficult to read. So what we usually do, and this is where I was talking about that ladder thing, we usually just put the if right next to the else. So we end up with something that looks like if condition statement, else if condition statement, and then optionally some more else if condition statements, and then finally an else.
Do you need that if
If you are going to put a condition, you need to put if. You can, so some rules that books usually enumerate. In an if statement, you must have one if. You must have at least, no, you must have one if. In an if statement, you can have 0 or more else ifs. In an if statement, you can have 0 or 1 else's. That else must occur at the very end. So it must be if, a bunch of else ifs, and then an else at the end. And that's pretty much the if and the else ifs are conditions you're looking for, and then the else is a catch-all. Anything that's not handled before then drops through to the else, and whatever's in the else is executed. Okay, that makes sense because when they talk about switch statements, the default action is actually labeled default.
So the else is just a branch of the true false thing. If it's true, then go for the default action.
Mm-hmm.
If it's not true, then go for this ladder function.
Right.
Essentially.
Right. And you can actually, if you were to draw a picture of, let's say, this program, for instance, programs are usually drawn with a circle at the top that indicates the start and an arrow going down indicating flow of execution. Usually rectangles represent specific actions and diamonds represent decisions. So here you could represent this as a circle at the top, an arrow going down, hitting a decision, and it's basically a three-way decision. Technically, it's a two-way decision, and then the else branch has another two-way decision. But the construct is so well used that we might as well just talk about this as a three-way decision. We have if val is equal to 5 or 7, we have val is equal to 6, and then we have our else case. Have I run this yet? I think I ran it before when it had some extra curly braces. This program is identical to the other one, just with some cleaner code. So questions on if statements?
So on that last if statement, you don't even need the curly brackets, do you?
Line 19? Well, 19 through 22, I need the curly braces because 23 and 24, I want to execute. I want both of them to execute if nothing else is executed.
Okay, so you only have the one statement, then you have curly braces?
Correct. Since line 20 is the only statement inside this else if from 19 to 21, I could get rid of those curly braces. In my opinion, and again, this is just personal preference, I think it looks weird to have an if with a block followed by an if with a single statement without a block surrounding it. Even if it's just a single statement, it just looks kind of unbalanced. So I usually try to stay consistent. Either everything has curly braces around it, or nothing has curly braces around it. As soon as I have one piece that has two statements in it that requires curly braces in order to compile correctly, I put curly braces on everything.
This is what we're talking about with the top down and the execution is size of the place to evaluate each expression and then you get it right or then you guess.
I guess that could be one definition of top-down. There are at least two other definitions of top-down that I can think of. We talked about one in Visual Basic, the top-down programming idea, which we'll talk about in this class when we talk about methods, which is when we discuss it in Visual Basic as well. Other way around. We start with bigger problems, break them into smaller problems, solve the smaller problems first, and then chain them together to solve the bigger problem. Looks like the book has some cool diagrams. So here I just use the equal to comparison. There are several different comparison operators. Equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to. I think I got them all. Yeah. And they're listed at the bottom of page 145, both in terms of what you see in a math course and in terms of what you write in Java. In the case of greater than or equal to and less than or equal to, the equal sign is always the second character in the operator, and there cannot be spaces between them. I know that the less than or equal to operator looks like an arrow pointing to the left, and it would be really cool if the greater than or equal to operator looked like an arrow pointing to the right. It doesn't. That will not compile. Java throws up on you. That's not a valid operator. The greater than or equal to operator is the greater than symbol followed by the equal sign. At the top of page 146, the book mentions a gotcha, and I guess technically it is a gotcha, but Java will complain if you try to do this. You cannot perform an assignment in a Boolean expression. It does not work. Java does not like it. Java will not let you do it. The test for equality is two equal signs, one right after the other. A single equal sign by itself is the assignment operator, and the two are completely different and can't be used in the same contexts. They don't mention the reverse case if you accidentally hold your finger too long on the equal sign when you're trying to do an assignment. As long as you're not also declaring the variable in the same statement, that is actually a valid statement. An expression by itself that's not being assigned to anything. And what will happen, so for instance, if I do something like, this should compile. Okay, it doesn't anymore. Java got smarter. That used to compile. That used to work fine. And it would evaluate that expression and do absolutely nothing with it. Now it says this is not a statement. I hope I don't have any code that uses that and assumes that that works. What else do we have? Okay, page 151, testing strings for equality. Up until this point, we've treated strings basically like primitive types, like the ints, the doubles, the longs, the shorts, and so on and so forth. Here's one case where strings do not behave like primitive types. You cannot say, For instance, system.out.println that will print false. Or a better way to say that is, this will not, under any circumstances, ever return true. Let's comment out all this other stuff, so I don't have to enter a number. So remember last class when I talked about making programs where most of it was comments? Here you go. Here's a good example. Okay, hang on. Yes. That will not under any circumstances return true, except in this case. I'll explain why in a minute. So this will not under any circumstances return true. The compiler's outsmarting me. Hang on. Let me see.
H little.
Well, then it's not the same string. Let's see. What am I trying to do? I think I can. Let's do something creative. No. S2 equals. There we go. So the compiler was in fact outsmarting me. In this case, if we were to print out both S1 and S2, they would both print out the text capital H, lowercase e, L, L, O. However, they point to different strings because strings are not primitive types. They actually exist in memory somewhere, and all that S1 and S2 are is basically something that points to those places in memory. The reason the first thing worked that I tried to do when I had the literal string hello is that Java creates a literal string hello somewhere in memory, and then it says strings are things that are often reused. So why create a bunch of copies of strings that all have the same information in them? So I create a string literal hello, Java creates that somewhere in memory, and anytime I use the literal string hello in my code, Java says, oh, I know where that is already. I don't have to make that again, and assigns that to the string. So in that case, S1 and S2 did point to the same place, so S1 is equal to S2, printed out true.
Why is that still the case when you concatenate?
Because Java optimizes my code and says, you're taking a literal string and concatenating it with another literal string. Let me take out the concatenation process and just make one literal string.
This one does work because you're pointing at S1 and pointing at S2 and S2 pointing.
Yes, yes. So I say S1 has the content hello, S2 has the content H. So at that point, at the end of line 16, S1 and S2 point to two completely different places. Line 17, at that point, at compilation time, Java has absolutely no idea what is in S2. So it turns 17 into the instruction, take the contents of S2 add ELLO to it, and store them back in S2. And it's still a different, completely different string from the hello string that's stored in S1.
Does Doctor help with this mode make it true or false when you do like two equal signs?
That's part of Java. So system.out.println, actually, there is a version of system.out.println that takes a Boolean, and if that Boolean value is true, it prints true. If the Boolean value is false, it prints false. There's another thing I wanted to mention, but I don't remember what it was. Oh, right. Strings are also immutable, which means you can't actually change them. So when S2 is added, or ELLO is added to S2 and stored back in S2, that S2 plus ELLO creates a completely new string. So now there's a third string in memory, and S2 is told to point to it. Even though strings can also do the plus equals thing, that doesn't make S2 suddenly contain ELLO as well. It creates an entirely new string and stores it in S2.
Basically, maybe
An unnamed string, yes. So let's do something really creative. Based on what I just said, what will this print out?
false.
I hope I'm right about this. It prints out false because it takes, even though S1 and S2 start out pointing to the exact same string in memory, adding world to S2 makes a completely new string and stores it in S2. Adding world to S1 makes a completely new string and stores it in S1. So now they're pointing to two completely different strings that both have the same text in them. Most of the time, we really don't care about whether a string variable is pointing to the same place as another string variable. That's usually not what we're after. So there is a string has an equals method, which is defined to compare the contents of the strings. So compare first character to first character, second character to second character, and as soon as you hit a mismatch, return false. Sorry. As soon as you hit a mismatch, the answer is no, they are not equal. We haven't talked about return values yet. But if you get all the way to the end of the string and every character is the same, the strings are equal. So that gives you a true or false value depending on whether or not the strings are equal. So in this case, we should get an output of false true. And that is in fact what we get. Questions on that?
Is that case sensitive?
That is case sensitive. There is a version of this method that is not case sensitive, which is equals ignore case. And both of those are at the bottom of page 151.
Does it just compare the
I don't actually know what the how the method is implemented. I think the idea is that it shouldn't actually matter how the method is implemented. Java by default uses Unicode, UTF-16. So it's possible that it just compares the numerical value. I don't think it does any conversion.
On page 86 of the book,
Yes.
it says 2 lowercase and 2 uppercase.
Mm-hmm.
If you use those, is that a problem with them?
So those are methods that you can call on a particular string, and those return the string that they're called on converted to the particular case. So let's demonstrate that. So S1 is X equals S1 dot, which one do you want? Capital C?
No. Yeah.
Does that answer your question? To some extent?
Yeah.
Okay. What else? I'm sorry?
Why do you have 2 backslashes over that final S?
What was that, 153? Yes. So he's basically saying that there are 3 possible cases. I'm specifically testing for 2 of them, and then commenting that the else handles the 3rd case.
So if you put that in your code, how would that work with the 2 brackets and the front now? Comparing and I get how you don't compare the 2 values trying to get different paths.
So that last part after the else is just a comment. So when Java compiles it, it completely ignores it. So that system.out.println S1 equals S2 is just it's the 3rd case. It's the default case I think you've mentioned. So there's also kind of a shortcut for if statements. If you're comparing relatively small things and maybe choosing one of them, for instance, if you're you want to choose this kind of uses the sure. If we want to pick the minimum string out of these 2 strings, we can do something like let's say we want to pick the minimum string. So if S1 not compared to S2 is less than 0, that means S1 is quote unquote less than string S2. And at this point, we realize that we want to do it all in one statement. There's this kind of weird operator, sometimes referred to as the ternary operator, implying that there is only one ternary operator, which is accurate because if you had any more than one ternary operator, languages would be confusing. That means it takes three operands. The first operand is the condition. The second operand is what to do if it's true, or the value to use if the condition is true. And the third operand is the value to use if the condition is false. And these three operands are separated by a question mark and a colon. So you have condition, question mark, true case, colon, false case.
Well, if you're just going to print what's in the bracket, it's just not print on it.
So what will happen here is that this expression will be evaluated. And whatever the value of that is what gets printed. So in this case, I think it should, let's see, S1 is uppercase, so I think it should print out S2. And it prints out S1. I guess capital letters are less than lowercase letters.
Well, are you doing the lexicographic order?
Lexicographic order, yeah.
Well, in the book it says it gets a negative number.
Yes, which would be less than 0.
Oh, so it's print of S1.
Right.
So it's not comparing the length, it's comparing the value of where they're stored.
It's comparing, so the idea that one string can be less than another string is kind of weird. I guess in terms of how you would look them up in a dictionary, is really what it's going for. So there are a lot of different things going on. There's the letter it starts with. There's the capitalization of that letter. I guess it makes sense that it gives rules for lexicographic ordering.
Yeah, it does. And the capital letters are all before the lowercase letters. So it compares them.
Capitals start at 42.
48, yeah, you basically got it.
40.
No, your capital would start at 65 and end at 90, and then at 97.
Is okay.
Lowercase letters.
Okay.
So it lists out the twice, but in
Mhm.
the book it says to mitigate that, you convert them all to the same
Case.
two lowercase.
Right. So lexicographic sorting is like you'd find in a dictionary. So you have the letter, the capitalization, and then if the words up to a certain point are exactly the same, and one doesn't have anything after that, I think it gets sorted before the longer one.
Right, so is it totaling the locations and then finding the difference between the two of them?
No, I think what it probably does, again, I haven't looked at the implementation for compare to, but I think what it probably does is look at the first letter. If it's ignoring case, it looks at the first letter. If it can determine the order based on that, it's done. If they're both the same letter, then it looks at the case. If one's capital and one's lowercase, the one that's capital is less than. Otherwise, it goes to the next one, all the way up until whichever one is shortest. If it can't figure out which one is less than the other one when it gets to the end of the shorter one, it says the shorter one is first.
So in that code, if you put a greater than sign before the 0,
If you put a greater than sign, it would show the maximum one, the one that's greater than.
yeah, so like in that code, you put a greater than 0, S2 would come out, so that's 1.
Yes. And in this chapter, they also mentioned the system.exit method. This basically says, Java, stop doing what you're doing, just end the program now. That's something useful if you use an if statement to look for error conditions. If you're looking for an integer less than 10 and I type in 999, you can say if this integer is 10 or greater, print out some error message and then system.exit, just end the program right there. Alright, so we've talked a lot about Boolean expressions. Those are the conditions we use in if statements, and we've also printed out some Boolean expressions. Here's a Boolean expression, here's another Boolean expression. Boolean expression is basically something that evaluates to true or false. It turns out that there's also a variable type called Boolean. So we can save the values of these expressions into a variable. And it is exactly the word Boolean. So if we wanted to save the result of this comparison, we could do that. And then we'd have, of course, we know that the name of the variable is actually incorrect. It's comparing where the strings point to, but I've never been the greatest at picking good variable names. So taking a Boolean expression on the right and assigning it to a Boolean variable. That's basically all of section 3.2. Already did. That's this, the ternary operator with the question mark and the colon. So, very quickly, I'll talk about switch statements. So, especially when we're testing, let's comment out this stuff and uncomment the other part. Go back to where we started. So often we have things that look like this. We have a primitive type. Switch statements only work with primitive types. They do not work with objects. You can't use them on strings, for instance. We often have a primitive type that we want to compare against a bunch of other primitive types, and we have a lot of cases. So if this if statement extended and had 12 different else ifs, that's a lot of code to write. That's really tedious. But there's an easier way to do that. This switch case statement basically says switch, take this value, and then each of the cases is compare it to this other value. If it's the first one, execute the first case. If it's the second one, execute the next case, and so on and so forth. And then there's also a default case called very simply default. If it doesn't fit into any of the other cases, that's your catch-all, for instance. So if we wanted to turn this if statement into a switch statement, first I'll write it directly below it so you can see the differences. And one clear indicator that it might be easier to use a switch statement as opposed to a bunch of if-else statements is if you're comparing the same variable lots of different times. So we'll start with that. That's a switch statement that doesn't do anything. Perfectly valid. Doesn't do anything.
Also, so you have to have at least one switch that cases a lot of that.
It's not meaningful to not have any cases. I will say that. But this by itself should compile, yes. But that's absolutely meaningless. This code does not do anything. So let's start with the first case that we have, which is 5. And
So this is cases and method, right?
there are no methods here. This is a single construct.
Oh, okay, so 5 is the variable that it's choosing. If they said 5.
Yes.
Okay.
Yes. This is basically if val is equal to 5, execute this next bit of code that I'm going to
Using case instead.
using switch in case instead. Correct. Yes, Joe.
Like I mentioned earlier, before class, you could put case 7 on, like, right next to case 5, but if you did it, it's the same thing. You did it for the right statement and
Yes.
case 7.
So, case statements, or the what do I want to call it? The body of a case statement, the statements that will be executed if that case is true, can be completely empty. And if you don't want anything else to be executed inside the switch statement, execution will fall through to basically what's in the next case statement. This statement, or this construct here, is really nothing more than a label, just saying, here's a particular place in the code. It doesn't say, this is where a particular piece of code begins and ends. Just, here's a particular place in code that you might want to go to. And the switch val part handles which of these labels to jump to. After that, it's up to you to figure out where you want to go. If you have a break statement at the very end of the case, that's the last thing that gets executed in the switch block. If you do not have a break statement, it just falls through to the next case. And that's described in more detail. That's one of those subtle things. It's the first gotcha on page 177. If you test a program that contains a switch statement and it executes 2 cases when you expect it to only execute 1 case, you probably have forgotten to include a break statement where one is needed. Frequently, it's used in a case like this where the things to be executed when val is 5 and 7 are exactly the same. So I say case 5, immediately case 7. Basically, if val is 5 or 7, Java goes to the same place. And fix my indentation.
Do you need a break after default?
No. Java might complain, but technically speaking, you do not need a break at the end of default because there's nothing more in the switch to execute.
Is it only example?
It's good practice to do that. But it's not absolutely necessary. So instead of having an else, I have default. And speaking of breaks, what did I forget? Right here. I need a break there. So we'll leave that break off and see if, I believe it should compile. Yeah.
It's just a good habit to put the break in.
Good habit to put the break there at the end, just to reinforce the habit so that you don't accidentally forget it at the end of the case. Forgetting it at the end of the case is very irritating. It's one of those bugs that goes in the category of really difficult bugs to track down. So this is printed out by the series of if statements. This is printed out by the switch statement. Basically, the switch case construct is a an easier way to implement a very specific instance of an if-else sequence. Questions?
So the reason that is 6 to
Correct. Yes. If I typed in 5 or 7, case 6 would not execute because I have that break there. This chapter also talks about something called enumerations, which are work really well with switch case statements. Enumerations are basically a list of names that are significant only in that these names go together in some way. So instead of saying, for instance, using integers to represent different states, you can give them all names and then use the names because they're actually identifiers in Java. You don't have to worry about misspelling something. If you misspell something in an enumeration, Java will complain, Java will break, because using that value somewhere else won't work. It's kind of a specialized case of named constants. So if you have a named constant for, let's say, 5, the correct answer. Another one for 7, the correct answer. Another one for 6, which is a close answer. There's no way of grouping them together because they're all just named constants. They're variables, final variables that have been given a value. You can use them in your code, but there's no visual indication that they're at all related. So I'll put this up at the top. You don't need that before the enum, but in general, it's a good habit to have a visibility modifier, which is what that public thing is. If you want it to be static, which we'll really explain what static and non-static means later on, you should have that. Enums should be static. I won't get into why, but they should be static.
Will work without public static, and you're saying it's better than public static.
For now, it'll work without the public static. It won't work without the static. For now, it'll work without the public.
Right, so you need static before you need public.
Yes. For now, you need. In this case, you definitely need static.
Yeah, I was asking about this case.
Yes. We'll call it answers. Enums follow the same naming conventions as classes. So the first letter is always capitalized. Any additional words, their first letters are capitalized, and the words are all smashed together. So we have, let's say, 5, 6, 7. Actually, we'll do that. The reasoning for that is that enums are actually ints in disguise, and Java numbers gives these names numbers starting at 1 and going to however many you have. So 1 will get the value 1, 2 will get the value 2, 3 will get the value 3, and so on and so forth. It just knows to do this. That's the way Java works. I think there's actually a syntax where you can specifically say this named piece of the enum should get a particular value, but I forget what it is right now. We need to end that with a semicolon. And then down here we can change this to 5, 7, 6. Right. Answers. Dot 5. I did call it answers, right? Not answer singular. Answers.
So in cases in the colon, just a semicolon.
Yes. It is looking for an integer. So we can probably do something like that. Ooh. Let's make this really contrived. And change this if statement to if it's 5, answer is equal to 5. Else if 7 answer equals 7. The idea behind an enum is that you're really not supposed to care what the actual value of the keyword is. What is it, 6? Otherwise, we'll do that. And then we'll change this to answer and now it should compile. What? Apparently, Dr. Java, I, and the book are disagreeing on how this should work. Yes. This might be something that's changed between Java 6 and Java 7. I know this syntax will work in both. Enum switch case label must be the unqualified name of the enumeration constant. So I can't put answers there, but I have to put it when I'm actually using the value. I guess because at this point it already knows what type it is. It knows it's the enumeration answers. So now it just looks in it in answers and for 5, 7, and 6. And now, after all that, we can run this and type 5 and everything works. So that's a long roundabout way of demonstrating enums. Any questions on chapter 3? Okay, so 10-minute break, and when we come back, I'll have some exercises that we can do.